Hi everyone, in this video I'm continuing to work through question 13 part C of the 2020 North Sydney Boys Extension 2 trial exam. So in this video I'm going to continue to work through part 2, which wants us to find the sum of the area of the shaded region, which is made up of rectangles that sit beneath the curve. Now in some prior videos I've already worked through what the result would be if n was an even number. So we're dividing up our range into n equal parts. We've worked out what it looks like when n is an even number, but what we need to do now is work out what it looks like when n is an odd number. So if you haven't already seen my videos where I work through the even case, definitely take a look, because the techniques I use there are essentially being replicated now, just for this other case where n is odd. So just like I did last time with the even case, what I'll do is I'll start with an actual example. I'll pick a value for n. We'll take a look at how that turns out. And then in a follow-up video to that, I'll then see how we can generalize the result. So yeah, let's take a look. So once again, I've created the diagram of the curve we're concerned with, this square root of x2 minus x. It's a semicircle, as we realized in part 1. But now what I want to do is let n is equal to 5. So if I just turn back to where we began with this part 2, we began by thinking about when n is equal to 4, and we saw this result and we worked out the value, and then we generalized that to the even case, and then we were able to check, did we get the same result, which we did, which is good. So now we're going to repeat the process. We'll let n is equal to 5, see what we get, and then that'll give us a kind of numeric check for when we try and generalize. So what we do, I'll just use another color. Let's divide this range from 0 to 2 into 5 bits. So if I was to go 2 divided by 5, it's going to be 0.4 across. So let's just get out the ruler and do that. So actually that's 0.5. So I'm kind of going to be 0. So about there. And then about there, and then just get my calculator to help me. Oops. So so 0.8, 1.6. Oops, let me just make sure I'm doing this right. So 2 divided by, so it's actually 8, because I've got 8 centimeters. Yes, 1.6 plus 1.6 plus 1.6, yes. So we're going to get to 4.8, and then we go plus 1.6 is 6.4. So these are going to be my verticals. And just like last time, our outside rectangles effectively have 0 height. And then if we're doing the inside rectangles, we get from here to here. And then actually from here to here, we skip over the midpoint, which is already different to our even case. And then we'll have this rectangle here, which again should be the same height if I wasn't so wonky with my semicircle. So in terms of comparing this, what we see here, the area of these rectangles, compared to, let me just flick right back to the case where n is equal to 4. So when n was equal to 4, we had 2 rectangles that we cared about, because the other 2 are effectively no height. Now when n is equal to 5, we have 3 rectangles that we care about. And when n was equal to 4, we knew we were going to have this line, or we did have this line that kind of split the range perfectly in half. But when n is equal to 5, we don't have that. We kind of skip over the midpoint, which I guess makes sense, because we're dividing this into this even number 2 into an odd number of equal parts. So you're not going to end up slicing it in 2. So this gives a hint that actually when you are dealing with odd numbers, it is going to be a different result. And actually, when I was first thinking about this question, as is often a good strategy with these kind of questions, you start picking numbers and see what you get. And it was through that process that I realized, hey, it's going to be different for even and odd numbers. So now let's go, okay, well, what is this area going to be? Again, it's just rectangles. We know the width in this case is 2 on 5 of each of our rectangles. And this will be f of 2 on 5. This will be f of 4 on 5. Now, this is technically f of 6 on 5, but these 2 points form the same rectangle, so we don't need to do both. So then we go straight to f of 8 on 5, and then that's it. So in this very specific case, our area will be equal to the width, which is 2 on 5, times the height, which is f of 2 on 5, plus the width, which again is 2 on 5, times the height, which we can pick either, but I'll just pick f of 4 on 5. And then finally our width, which is 2 on 5, times the height, which is f of 8 on 5. So again, let's just factor out our 2 on 5. So it'll be 2 on 5 times, and then we'll put our values into our function. So it'll be the square root of 2 on 5 times 2 minus 2 on 5, plus square root of 4 on 5 times 2 minus 4 on 5, plus the square root of 8 on 5 times 2 minus 8 on 5. Bracket. So that's 2 on 5 times, and let's just get simpler square roots, so I'll use my calculator for that. So 2 on 5 times 2 minus 2 on 5, that is 16 on 25, so the square root of 16 on 25, which will just be 4 on 5, plus, now we'll do 4 on 5 times 2 minus 4 on 5, which is the square root of 24 on 25, plus, and I know this will be 16 on 25, but I'll just key it in just to check, 8 on 5 times 2 minus 8 on 5, 16 on 25, very good. So square root of 16 on 25, so it's going to be 2 on 5 times 4 on 5 plus root 24 on 5 plus another 4 on 5. Now, it might be a bit rough to try and totally simplify that like we did for the even case. Maybe I'm just going to throw this into my calculator and just write it out to a lot of decimal places, and that'll give us the precision we need for our check. So it's going to be 2 on 5 times bracket 4 on 5 plus the square root of 24 on 5 plus 4 on 5. So that's going to be 1.031918359 and so on. So if we can generalize this result, and when we plug in n is equal to 5 get this exact number, then again it provides some level of comfort that we haven't stuffed anything up. So what I might do, just like last time when I was doing the even case, I might stop here, and that'll give you an opportunity to think about how you might generalize this, what's the general pattern, and then I'll see you in the next video where we work through how to generalize it together.